Hello, I am Nakul Navarange and I am a wireless systems engineer at Qualcomm. In my role, I get to witness firsthand evolution of some of the upcoming wireless technologies and their multiple applications that have the potential to revolutionize pretty much every single aspect of our daily lives. Additionally, I belong to the Qualcomm Wireless Academy, which is the training and educational arm of Qualcomm. And as a leading instructor for the academy, I often get the opportunity to interact with and educate students, my fellow engineers, as well as business leaders in the industry on multiple upcoming wireless technologies. And one wireless technology that definitely has garnered public attention lately is 5G, which is the fifth generation of cellular communication standard. It is a technology that rightfully has everyone excited with its potential to revolutionize every single aspect of our daily lives and make our life better in multiple different ways. But while it is an exciting technology and people would like to learn more about it, very little is available out there that can help us understand in simple language what 5G really is. And that is exactly what brings me here today. I am here to help you take your first look at 5G, help you understand right from the basics what 5G is, what are some of its key features, what are some of the novel applications it can enable, and importantly, why exactly it is just as groundbreaking as everyone says it is going to be. I hope you're excited to learn more about 5G. Let's get started. Before we can learn more about 5G, we have to take a few steps back and understand how we got here. And that takes us all the way back to 1970s and 80s with the first generation of cellular communication, now retroactively known as 1G. The primary motivation of the first generation of cellular communication was to enable users to make and receive voice calls even if they weren't at home or in their offices. The purpose was to enable them to make and receive those voice calls on the go, pretty much no matter where they were in the city. And that is what made wireless communications truly mobile. Then came the second generation of cellular communication sometime in the 1990s, and the focus was still on providing voice services, although there was one significant change. While the first generation carried your analog voice in analog format, second generation carried your analog voice in digital format as a stream of bits and bytes for two important reasons. A, because digital voice offered significantly better voice quality as compared to analog voice. And secondly, digital voice, it being more efficient than analog voice in its transportation, enabled the network operators to use their networks with more efficiency and hence expand their capacity as compared to 1G networks. But the focus nonetheless was still on providing voice services, although some ancillary services such as SMS or text messaging were also introduced at this point in time. The generation that truly allowed you to browse internet on your phone was 3G, commercialized and introduced around the turn of the century. It was the generation that truly put internet in your palms by allowing you speeds of a few Mbps and hence allowing you access to different services offered in the internet domain, such as news, weather, and other simple services. So this was the real introduction of internet in your palm. Although let's keep in mind that because data speeds were limited to a few Mbps in most cases, there were limitations to what you could do at that point in time. That significantly changed with the advent of the fourth generation of cellular communication known as 4G or LTE. 4G significantly redesigned the cellular networks and some of the protocols using which they operate. And as a result of those redesigned decisions, users were able to get bit rates on the order of a few hundred of Mbps or sometimes even more than 1 gigabits per second. And as a result of these greatly expanded data rates or speeds or throughputs, as they are called by multiple names, we were able to expand our ecosystems to not just simple services such as news and weather, but more complex services such as high definition videos, or HD telephony, cloud computing, etc. And thankfully, that trend of ecosystem expansion has continued till date. In that, we no longer just have cell phones and tablets accessing wireless networks, but we have multiple other devices as well. We have fitness trackers, utility meters, we have smart home gadgets. Industries have thousands of sensors, or cameras, or robotic equipment, automated guided vehicle, etc. We have millions and millions of such devices trying to access the wireless network in order to do their daily functionalities. And that trend of expanding ecosystem requires us to ask one fundamental question. Are the current technologies such as 4G or Wi-Fi truly enough to meet the aggressive and diverse requirements of these expanding ecosystems, not just today, but 5 years and 10 years from now? Because objectively answering that question will tell us whether we need a new generation of technology beyond 4G, and if yes, what would be some of the fundamental requirements out of that new generation of cellular technology, which would be 5G. So let's take a few minutes and try to objectively answer that question, why we need a technology that is beyond 4G. And the answer to that question is given very colorfully along the periphery of this slide. These days, no matter where we are, we expect ourselves to be able to access our entertainment applications such as video streaming, music, etc., all of which are these days in increasingly higher definition. But not only that, individual users like you and I are generating more and more, as well as richer multimedia content such as pictures and videos. That means that the networks not only need to offer higher download bandwidth, but they also need to offer significantly higher upload bandwidths as compared to the days of the yore. Regardless of where we are, such as congested environments like a football stadium or a concert arena, we expect ourselves to be able to seamlessly use our phones at high speeds to share pictures and get updates about the events. And even if we are in a high-speed mobility scenario, such as a high-speed train, we fully expect ourselves to have the same seamless experience as if we are sitting at home or in our offices. With the advent of work from home and work from anywhere paradigm, we increasingly rely on cloud computing architecture of our universities or our offices so that we can exchange heavy files and documents back and forth with the cloud computing server without having to store those locally. And what that means indirectly is that you need a reliable and high-speed communication pipe between your machine and the server that you're trying to communicate with. And that is one of the newer use cases that has arisen lately. Immersive experiences such as virtual reality are becoming more and more commonplace in the entertainment and personal spaces, and augmented reality is becoming more and more indispensable in the research and scientific communities. And both virtual and augmented reality are a couple of typical use cases which not only require significantly higher bit rates, but they also require an underlying communication channel that is significantly faster in terms of packet delay and at the same time significantly more reliable than what the legacy technologies are able to offer us. In a matter of a few years, most of us will be riding in autonomous vehicles, vehicles that will need to communicate not just with the network and infrastructure, but with other cars that are present on the road around themselves. And as you can tell, that communication will need to happen with millisecond precision and speed. And that is also going to require an underlying communication system that can offer high-speed, reliable communication at millisecond or even microsecond level. And all these use cases and applications, although they may have sounded somewhat hypothetical or theoretical a few years ago, many of these use cases have already been realized or the others are very imminent. And that requires us to graduate to a networking technology platform that can offer us ultra high speeds as well as network capacity. It should allow for extremely low lag or packet latency or the time delay that it takes for a packet to go from one end to the other. The upcoming technology needs to offer significantly lower packet latency in order to provide for these real-time and interactive applications such as VR and AR. But not only that, These diverse services need to be provisioned under the umbrella of the same technology. It wouldn't be very difficult to provision a different network for each of these different services, but that won't be an economical choice after all. So we need a technology that can provide for all these services under a common unified framework or an umbrella. And in short, we need a technology that has the capability to connect everyone and everything. And any wireless engineer worth their salt will tell you that the current technologies such as 4G or Wi-Fi aren't exactly in a position to successfully meet all these requirements, not just today, but continue meeting those requirements 5 and 10 years from now. And that is precisely what necessitates the advent of the next generation of cellular technology, which is 5G. And 5G, as we'll shortly see, is a technology that has been designed in such a way that it becomes essential for offering all these next generation mobile experiences in a seamless manner with increasingly better user experience.